create manual space frame. im3d space frames are basically used to facilitate modeling concrete and steel structural members as well as applying load cases. Auto load distribution and structural analysis can then be performed globally to all structural members. There are two ways you can create a space frame, one is automatic and the other is manual. Automatic space frame creation uses the building boundary and the floor axis together with the number of floors to generate it. In this method, all floors are assumed to be typical. Manual space frame creation is a step-by-step method to model each frame element separately. This method is more generic and gives the designer more flexibility while it takes longer. The menu shown above has several commands that allows you to model manual space frame. The main icon loads this dialog box which allows you to specify the basic information about the space frame such as name, number of floors, floor height and slab thickness. You can also specify the slope of each floor as in modeling garage structures. This dialog box is used for both automatic and manual options. The Use Frame Axis checkbox specifies whether you already drew the floor axes and you want to use them as the frame base axes, will be discussed later. If this checkbox is left unchecked, that means you want to specify the frame base axes manually. After you click the OK button, you will be asked to select the building boundary and the axes if you checked the option mentioned above. Floor height and slab thickness are in centimeters for metric and in feet in imperial units. Frame name must be unique if you plan to have more than one space frame per model. It is recommended though to have one space frame per drawing. It is also worth mentioning that space frame is one entity even though it consists of many elements as we will see later. Also you can model your building without generating any space frames, however, you will not be able to apply loads nor will you be able to do structural analysis later on. By default the north direction is the AutoCAD positive y-axis while east direction is positive x-axis. You can change these settings as we will discuss it later on. Tip: generate one complete frame floor and after you model all other structural members, stairs, ductwork or any other building components, you can use the copy floor command, will be discussed later, to copy all these objects to above floors. Before getting into details, you need to get yourself familiar to some terminology used in a Model 3D environment. Please pay attention to the command prompt. Girder element: for concrete it represents a continuous beam while beam element represents a simple concrete beam. For steel, both girder and beam elements represent a steel beam. When modeling a frame, a girder element automatically generate beam elements between column elements. These beams will be hidden but will be used later in the analysis. Wall element represents a generic wall object that could be brick, lumber or any other material. While the space frame is a single object, you can view it in several ways, as will be discussed later. For example, if you can isolate one or more floors, hide one or more floors as well as frame 2D also known as frame axis. The frame base contains axes representing all frame 2Ds. No frame element can be constructed if it doesn't lie entirely on a frame base axis plane. This is essential for load distribution and structural analysis. The following is the description of each of the above menu items. Add axis, girder. This command allows you to draw a single base frame axis. It creates the base for a frame 2D which will be used to draw frame elements such as columns, beams, walls, girders and braces. As mentioned above, have these elements lie entirely in a frame 2D plane is crucial to the analysis. The following dialog box will appear as a result. Here you can specify the number of floors for this particular frame 2D as well as each floor height and slab thickness. Note that this command will not generate the frame 2D element but it will draw the frame 2D base axis and the data specified above is stored in it. After drawing this axis, you will be able to add frame elements such as columns and girders. Add axis, beam. This is similar to the above command except it generates a beam axis. Beam axis allows only beam elements to be drawn. Beam elements are those supported by main girders. The loads carried by beam elements are distributed to their supporting girders as concentrated loads. This also loads the dialog box shown above. Both commands ask you to select the frame base you have just created, then specify the start and end point of the axis you want to add. Remove axis allows you to remove an entire frame 2D by simply snapping to the axis you want to remove. Floor column. There are two ways to draw a column element, one is a floor column and the other is column, the next menu item. The difference is that floor column uses the floor height and slab thickness specified earlier to draw the column element. You only need to specify the insertion point. Column. Here, the following dialog box appears where you can specify the column height. If you wish to draw a column element in reference to an existing column element, check Reference to Existing option and specify the sloping angle. This is useful in creating sloped roofs. Beam. Allows you to draw a beam element. Beam elements can only be drawn on beam axis. You will be asked to specify the start point and end point. Note also that these 2 points must lie on column elements. No girder, beam, wall or brace elements can be drawn without being connected to column elements. These restrictions are important for the integrity of the space frame and are essential for the analysis as mentioned earlier. Girder. Allows you to draw a girder element. Girder elements can only be drawn on girder axis. You will be asked to specify the start point and end point. Note also that these 2 points must lie on column elements' endpoints. Wall. Allows you to draw a wall element. Wall elements can only be drawn on girder or beam axis. You will be asked to specify the start point and end point. Note also that these 2 points must lie on column elements. Curved. Allows you to draw a curved beam and wall simultaneously. You will be asked to specify the curved 3 points. A beam and a wall elements will be drawn separated by the slab thickness value. Brace. Allows you to draw a brace element. You will be asked to specify the 2 points. Braces must connect a column element top point at one end and a column element low point at the other end. Cantilever. Allows you to draw a cantilever element. You will be asked to select a girder or beam element and then specify the cantilever endpoint. This cantilever will be part of the selected girder or beam. Remove element. Remove any element by selecting it. Copy element. Copy any element by selecting it and specifying the base point and the new point.